Hi, it's Tom here from FDS, and today we are going to be looking at the single greatest leap forwards in easy flywheel modding since rewiring and rewire kits became a thing. And this is the finished version of the BSUK Mosfet board. Now, as you can see, there's the Mosfet here, and all the components that you need to convert your blaster to a Mosfet fed monster are all on the board for you already. To give you an idea of how big that is, if I just get, here's a jam door switch, so there's the two next to each other, a jam door switch, that is tiny, it's about twice the size of a FET, just. So what you're looking at is a pre-soldered board, and the only thing that you have to add on if you want to have a plug-in, this is what this is for, that's for a plug-in trigger switch, which I think is always a good idea, is this little header here that pops into those two pins there, and then you turn it over and you place a little solder on the contacts on the back and solder that in place. So what I'm going to do is I'm going to show you how to install this in your Strife, and the same method can be used for any of the two motor semi-autos, so that's the Modulus, the Demolisher, all of those. All can be done the same way. Obviously, if you need any further looking at MOSFETs, if you go look at my MOSFET videos, there's ways to do it with the components, and also the same wiring discipline applies. So I've got a Strife that I've been working on. So ignore this wiring at the top here, because that's all stuff for the LEDs that were already in the shell. This is a revamp of an old blaster of my son's. So what you've got, here's the first job. I'll just open this up so you can see what I've done. Is you can see there, I've just added that JSC connector straight onto the rev switch. This uses the stock rev switch. Now the reason that these are so amazing is because people struggle with MOSFETs. They are by far the best way to do this job. There are multiple reasons why. First of all, you do not have a big ugly blob of crap and some stupidly large micro switch in the trigger. You have no high current going through the palm of your hand. You also have the stock trigger and the lock here to avoid you from short stroking the trigger under pressure without pulling the rev trigger, which is the commonest way of getting a jam, and especially under stress if you're not a regular HVZ player or you are sometimes prone to panic, which everybody is when something jumps out at you. You might not always respond like a seasoned veteran. This will stop you from short stroking. You can lend your blaster to somebody, it'll function exactly how they expect it to function, and you won't have your mates going, "Oh, my blaster's jammed." And also, it's completely modular, so it allows you to build looms that are completely plug-in. Here we can see the motor plug, and then there's a plug-in micro switch. So if I want to, I can put a miniature micro switch like a Cherry DC2, which I think is vastly superior to the 21 amp Omrons that seem to be depressingly popular. But you can put a DC2 in here if you want the trigger feel. I know some people rat on about that. I've never felt the need to myself. So what I've got is I've got my little blaster board here. Now when you turn it over, I'll take the header off, it actually tells you what the connections are. So what you've got there is on this one, this side, it says battery red, right? That's the main battery lead there, right? To the battery. This side, ground, black, right? Battery, main ground. And then there's that one, which just goes to the motors. And that's it, 3 wires is all you need to connect, and you're ready to go. So if you've got a blaster you've already modified, you can take out everything except the wiring from the trigger, and then the trigger just plugs into the headers there like that. That's it, and it's ready to go. So I think that is brilliant, because it means that you can now run any motor combination you want from stock right the way up to top tier stuff that's drawing like XP180s that can draw huge currents. It'll all quite happily run through this. It's perfectly safe, and the board is manufactured in Great Britain to a very exacting standard, and there's no janky soldering to do. You literally take the board, solder it up. All you have to solder is these two little connections on the back here to take the switch. You can just put the wires in there if you want, but I always like plug-in. So without further ado, I'm going to crack right into soldering that. So as you can see, I've got my 2 battery cables here. I do have to put a feed off this, so you're going to have to wait while I just put a feed off this cable, and then I'll come back and do the connection. Okay, I've got round that little bit that I had to do. So I'm starting with my FET board, and ignore the little wires, because that's all just the LED stuff. My son likes his little toys and his bits. I'm just putting a tiny bit of separate flux. If you've got a nice little flux application tool that works for you, then use it. So what I'm doing is I'm going to just put a little bit, this is called tinning, so I'll just put a little bit of solder onto the board pad, not much. You don't want to pause too long on boards, remember. Electronic soldering, faster. I'm just making a little pad on there. Right, I'm pretty much ready to rock and roll now. Okay, so I've installed the wire with the split now, so obviously red wire straight to the motor, and then a spur coming off the main battery cable which is going to feed the switch. So I'll start with that one and we'll go from there. Now this is really simple to do because you don't have to worry about what goes where. Remember, turn it over and read on the back as per all circuit boards. This is already tinned, so it won't take very much heat. Don't sit there for hours, you just want the solder to go nice and shiny and then get a good connection. Watch out for a dry join there. And then the next thing to go on is the other main battery negative. I'll just pass that around the back. Again, watch the temperature. So again, there's two, and then the last one. This has got to be the fastest FET in history, surely. So the final one is just this connection onto the end pad here, which is going to be the output to the motor. It's wiggling it into place. It's going to be the problem now. I might need to get my self-gripping pliers. Right, again. Just pause, melt the solder on the pad, don't go mad. Right, that's it. Last thing I've got to do is simply plug my switch in there, and that is my MOSFET board completely done. If you want to look at that in a little bit more detail, I'll just remind you of the connections. Main battery, positive feed from the main battery line, and then negative out, which you can do in blue or yellow if you're following their scheme. It does tell you on the back. And there's the wire going then to the motors, and you can see all of that's written on the back here. So remember that on the back, the writing on the back corresponds to the one directly above, the pin directly above. So you can see nice and tiny, and then all I've got to do is just tuck that wiring away, and you can secure that if you want to with a little double-sided pad into the corner. Now I've had to do a little bit more on this one because of the extra stuff, because there's additional wiring in there for the LEDs. That's what I like to use the stock block for. It's really good for that. So there you can see that is all sitting well below the height of the trigger, like that. Now all I'm going to do is I'm just going to put the test pack on the end and just make sure that it works as per usual. In this case I haven't fitted the battery connector yet, so I'm going to use some croc clips. Don't use uninsulated croc clips with a LiPo on the end, that's exceedingly stupid. You'll see that I'm using a shit tier C-cell pack. So connect that, and then input for that will take any voltage you like. You can run whatever you want up to that. I think it's rated up to about 6 amps or something ridiculous. And ampage wise, really high amps. It'll run anything you want ampage wise. And as you can see, that is working perfectly. So I'm done with that mod, and that is how you install your MOSFET board. Now these are going to be available in the next month or two. You'll have to keep your eye on the Blastersmiths page and have a good look there and see what's what, and I can promise that those will be out sometime in the next couple of months. And do ask Mike at BSUK if you've got any technical questions, because I've just installed this one so I can go to a war this weekend and try it out.